this video will cover section 1.8 inverse function. So from section 1.7, we went over composite functions, right? And even though the functions are not the same as the ones we worked with before, I think you guys could recognize one of them, right? The one of the computer price minus 300, the one with a discount of $300. So that one is here. However, we don't have the other function with the 85% of the regular price. Instead of that, we have this function x plus 300. And so what we're going to do here is, and it's kind of like almost done for us. We have the composition of f of g of x. And so we already know that that is equivalent to this expression. And so what we're doing is we're going to have replace the x in f with function g. Right? That is what we're going to do. So if we do that, Alexandra, or Alexandria, tell me what is function g. Just read it.
It's x plus 300.
X plus 300. So that will be the same as function g, right? And so if we continue with function f, we see that, 300, sorry. So, and then we continue with function f, we have a minus 300. And so if we combine like terms, the constant terms, 300 minus 300, that will equal 0. So the result for that is x. Okay. So when that happens, well, let's see if it is true. Let's do it for both. So now I would like for you guys to do the following. Let's find g of f of x. And so you guys already know the function that comes second, that's the one inside the other. This will be g of f of x. And so we know function f is this one, x minus 300. And so what we need to do is take function g and substitute this little x here with x minus 300. So that will be x minus 300. But let's not forget there is a plus 300 here. And we get 300 minus 300 is equal to 0, or you may say they cancel. So we have x. So if you guys notice, the first composition that we did, we ended up with x. So that means we satisfy this condition. Now the second composition we did, g of f, we also ended with x. So that means we satisfy the second condition. Now when those two conditions are met, we say that one function is the inverse of the other. Okay? And so now instead of calling that second function g of x, I could go ahead and call it f inverse of x. And it's not that we're raising it to the power -1. It simply means f inverse of x. Okay, so the f in the -1, that means f inverse. All right, we have a table of values here for you to see. And so one thing about inverse functions, I don't know if you remember from Algebra 2, but they are reflected across something. Do you guys remember what it was? It's not the x-axis or the y-axis. Y equals x. Very good. So they are reflected across that function, which is the parent of linear functions, right? So if we do an operation like the ones we were doing before, let's see. So this will be f inverse of f of 1300. So remember, the second function is the one that goes inside. So now let's use the tables that we have here. And so we have f inverse. So we have f inverse of the f of 300. So what is if the input, we're going to look at this function first. If the input is 1300, what will be the output for that? 1000, right? So f of 1300 is 1000. Now if we look at our second table, which is here, if the input is 1000, the output will be 1300 or 1300. And isn't it that what we started? Yes? So in terms of that problem of the computer with a discount, it's kind of like, yeah, you get the discount, but they charge you again. So you didn't get a discount. You ended up paying the same price. Okay, so let's go to the next slide. And we have here the definition of the inverse of a function. And so we start with, let f and g be two functions such that f composed with g gives you x for every x in the domain of g. And if we do it the other way, g composed with f, we also get x. So when that happens, we could determine that f and g are inverses of each other. So in other words, one will undo the other. Let's talk a little bit about other type of inverses. So let's say with numbers, real numbers, they have a thing called a multiplicative inverse. Multiplicative inverse. And that will be something that you multiply 3 by to get a 1. What would that number be? 1/3. Because if we multiply 3 times 1/3, we will get 3/3, which is equal to 1. Now, there's something else called for real numbers called the additive inverse. And so that will be a number that when you add it to that number will give you a 0. What number is that? -3, very good. So 3 minus 3 is equal to 0. So the multiplicative inverse is this one. The additive inverse is this one for that particular number. And I like to explain this because this will become very useful when we get to chapter 8 with matrices, where we're going to have to do Gauss-Jordan by elimination, by hand. So these two concepts are very important. They're so important that they have a specific name. And so number 1, it's called the multiplicative identity. Of all real numbers. And 0 is called the additive identity of all real numbers. Okay? So if Kimmy told me earlier, inverse functions, they are reflected across this line, y equals x. And we know that is the parent function of all linear functions, correct? But it also has a very special name. You guys remember what that name is? Where the input is the same as the output. It also starts with an I. Yeah, identity function. Identity function. All right. So let's go ahead and verify if those two functions are inverses of each other, and that will probably be the last problem of the day. Okay. So first we're going to compose f with g, and if we end up with an x, that means yes, it is true. So in this case, we're doing f of g, so we'll have function g inside minus x minus 2 divided by 3. And so function f only has one x right here. So we're going to substitute that x with the expression that we have here. So we have the coefficient 3, let's not forget about it. And then instead of x, we have x minus 2 over 3. And then we also have a plus 2 here. Now this requires a little bit of algebra, but it's not that hard because you guys know how to multiply fractions, right? Straight across. So 3 times x is 3x. 3 times negative 2 is negative 6. Now here we have 1 times 3, and that is just 3. We still have a plus 2. So I'm going to need more room. So if I split this fraction here, it will be 3x divided by 3 minus 6 divided by 3. We still have a plus 2. So 3x divided by 3 is equal to x. 6 divided by negative 6 divided by 3 is negative 2. And we still have a plus 2. So 2 and negative 2 equals 0. So we get x. You guys know when I started doing equations with you, I tried to use the word, what is the inverse operation of multiplication? And then you all say division. So I do that for a reason. Okay. Now, so it's true, right? So we satisfy the first condition. Now the second condition, we're going to do compose g with f. So in this case, it will be g of function f, and function f is 3x plus 2. Yes? Okay. So, okay. So what that means is that for function g, this little x here is going to be substituted with 3x plus 2. So we will have 3x plus 2. I need to see the functions. Minus 2 from here. And then let's not forget everything is being divided by 3. So here we could say, okay, 3x, but the 2 and the minus 2 are equal to 0. So we just have 3x divided by 3. And of course, we know that equals to 1, or you may say they cancel. So that equals 2x. So that means that our second condition, it is satisfied. So with that, don't pack your things yet. So what that means is that the two functions are inverses of each other. So we could say that function g is equal to the inverse of function f. Okay? So now you can pack your things. So we are done with the problem. We'll finish this section on Friday.